Hello, good afternoon. How are you doing today? Welcome to today's class with Mr. Kiki Manuel Gamdi. In our class today, we'll be taking a question from past IGCSE question paper. And here comes the question. The figure shows the sector ABC of the circle center C, radius 2r in centimeters, where angle ACB is 3 theta in radians. The points D, E, F, G lie on the arc of the circle center C, radius r centimeter. The point D and C are the midpoints of CA and CB respectively. Angles DCE and FCG are each theta radians. The area of the shaded region is 5 centimeters square. Roman figure 1. By first expressing theta in terms of r, show that the perimeter p centimeter of the shaded region is given by p is equals to 4r plus 8 over r. Given that r can vary, show that the stationary value of p can be written in the form k root 2, where k is a constant to be found. I determine the nature of the stationary value and find the value of theta for which it occurs. Okay, look at the diagram very well. We have a circle of sectors, concentric sectors. We have the center as C, we have D and G as the midpoint of the radius CB and CA. So we have the shaded portion marked with dotted lines. So let's answer the question. From the question, we have that the area of the big sector ACB is equals to half r squared theta, which is half of 2r all squared of 3 theta. So that gives us half of 4r squared 3 theta, which gives us 6r squared theta. Now, the area of the small sectors, the sector A, the sector DCE or FCG, the area is T. Using the same formula, we have half r squared. So that gives us half r squared theta. So because there are 2 of them, so we multiply half r squared times 2, it gives us r squared theta. So to find the area of the shaded region, we say 6r squared theta minus r squared theta, which gives us 5r squared theta. So we're given the area of the shaded region as 5. So we have 5 is equals to 5r squared theta. So making theta the subject of the formula, we have 1 over r squared as the theta. 1 over r squared as the theta. We have expressed theta in terms of r, which is theta is equals to 1 over r squared. Now the perimeter is given by the length of the arc. The arc we have AB, the length of that arc, which is 2r of 3 theta plus the radius, which is we have AB, AD and DC. That's r plus r plus we have CA, we have CG and GB, which is another r plus r, then plus the length of the arc, we have FG and DE. That's r theta plus r theta. So if we open up, we have 2 times 3, that's 6 r theta plus r theta plus r theta. That gives us 8 r theta, then r plus r plus r, that's for r. Remember, perimeter simply means sum of the sides visible. So if we substitute theta as 1 over r squared, we have 8 over r plus 4r. So we have proved the perimeter to be 8 over r plus 4r. Now to find the stationary point, we differentiate the perimeter with respect to the radius. So the PDR is negative 8 over r squared plus 4. So at this turning point, at this stationary point, the PDR is equal to 0. So we arrive at r as root 2. If we say minus 8 over r squared plus 4 is equal to 0, so that means minus 4 is equal to minus 8 over r. So minus cancels minus, r squared is equals to 2. So r is equals to root 2. In that case, if we have k root 2 as r, that means k is 1. That means k is equals to 1. That is a constant. To determine the nature of this stationary point, we find the squared p dr squared, which gives us 16 over r cubed. We substitute the value of r, which is root 2 there. We have 16 over 2 root 2, which is 8 over root 2. So which is greater than 0, which shows that this is a minimum point. So if we substitute this minimum point into the value of the perimeter, to the equation of the perimeter, we have the minimum value as 8 root 2. So to determine the value of theta, we have theta expressed as 1 over r squared, which is equals to 1 over root 2 squared, which is equals to half radian. Thank you for being part of our class. Please help us. Please share our video. If you see them in the Facebook, in the YouTube, in the LinkedIn, please comment for us. Please talk to us. Please share our video. Help us for the world to hear us. Help us for us to serve you better. Help us for the right person who needs our attention to get to us. You can talk to us through this contact 080-387-46884. God bless you.